In this video, we're going to show you how to complete the square. It's a method that we use for solving quadratic equations. To understand how you do that, you need to have a good understanding what a perfect square trinomial is. Now, we do know what perfect squares are. Perfect squares are numbers like 4, 9, 16, because they come from numbers that are squared. So they're numbers that are perfect in the way that they were squared. A perfect square trinomial is very similar. Instead of squaring a single number, we're going to be squaring what's called a binomial. The binomial that you square to make x squared plus 6x plus 9 is x plus 3. If you square this, this is what you get. Here's why. Make a little bit of room. If I were to expand this out to say x plus 3 times x plus 3, then we would use FOIL, and we get x squared, 3x, 3x, and 9. Adding up the 3x's in the center, and you see I get my x squared plus 6x plus 9. So that's why it's called a perfect square trinomial. And when you factor a perfect square trinomial, you get something that looks like this guy. What would be the factors of x squared minus 8x plus 16? Well, to get the 16, it'd have to be 4. It's not going to be a positive 4 because of the negative 8. There's the factored form of x squared minus 8x plus 16. So now, when we get the numbers get a little bit bigger, the way that we can kind of fill in the information, because in a lot of the cases you won't have the right perfect number. So what would be the perfect number to add to 16? The couple steps you do is step number 1. We take the b number and we divide it by 2. Then step number 2 is you take that number and whatever you get, you square it. That answer is what you'll plug in to here. So let's do it for real. 16 is our b, divided by 2, and you get 8. Square the 8, and you get 64. So our perfect number is going to be adding 64. The number that made the 64 was 8, so it's x plus 8. Let's try it again. Step 1, find the b number, 20. Then divide it by 2. I get 10. Then we square it, and we get 100. So the number we're going to add into this is 100. What was the number that made 100? Well, 10 times 10 makes 100. Perfect squares. So why is this helpful doing this process? Well, let's take a look at this. 6x plus 2. Any which way I try to figure out the factors of this, I'm not going to be able to do this. I can, if I try to do the magic x style, 2 on top, 6 on bottom, nothing's going to multiply to make 2, but then add up to make 6, because only 2 and 1 are going to make 2. I can't possibly add those or minus those to make 6. So factoring is not an option for this problem. Back that all up. So instead, let's make this perfect. First step is do what I call is make some room. So first up, make some room. By making room, I mean get rid of the 2. X squared plus 6x, there's my space, equals negative 2. So that step right there is I'll call make some space. Now we have to decide what's going to complete the square. So this is the complete the square step. So off to the side, I'm going to try to find the perfect number to make this into a perfect square trinomial. You take the b number, which is 6, you divide it by 2. We get 3. Then we square it, and we get 9. So I'm going to add 9 to this side. But in algebra, when I add something to one side, I have to add it to both sides. So if I add 9 to this side, then I also have to add 9 to the right-hand side. Okay, now let's go ahead and simplify. Negative 2 plus 9 is 7. And now I can rewrite this as my perfect x plus 3 squared is what this would turn into if it was factored. Okay? Factored. Now we can start to solve it. Our next step in order to solving it would be to get rid of the square root. So I square root both sides. Since I'm square rooting both sides, I definitely need to make sure I put positive or negative square root 7. And now the square and the square root cancel each other out, leaving me with x plus 3. Last step is to subtract 3 on both sides. And our x equals, we like to put the negative 3 first, then the plus or minus, then the square root 7. There are two answers. Okay? Do know that this is actually two answers if you really want to split them up. It's negative 3 plus square root 7, and it's also negative 3 minus square root 7. But leaving it like the way that I boxed is fine. In this, you do need to know when to make space and when not to. I'm looking at this problem, and I notice there is no number being added subtracted to the 8x. I don't need to make any space for this problem. I can go ahead and start to rewrite this with that open spot. There's my space, equals 9. And something will also go on that side, the same thing. You do have to complete the square for this problem. So make sure you realize that in this problem, b is equal to not 8, but negative 8. So we're going to take negative 8, divide by 2, get negative 4. Then we're going to square it, and we get positive 16. Since it's a positive 16, I'm going to add 16 to both sides. Now we write the factored form of x squared minus 8x plus 16. What perfect number made this perfect square trinomial? It was a negative 4. You can also look right here for that number. Write parentheses and square it, and 9 plus 16 is 25. Step to get rid of the square, the exponent, is the square root. Now those two guys cancel out. And our x minus 4 is equal to positive or negative 5. So this time I ended up with a much nicer number. Last time I had a 7. This time I have 25, so you go ahead and finish it. Add 4 to both sides. And we have two problems we have to do. We need to do 4 plus 5, but then we also need to do 4 minus 5. So our final two answers are 9 and negative 1. There's our two answers. Let's take a look at this problem. In this problem, we see that there is something being added to the bx, so let's get rid of it by subtracting 2 to both sides. Make space. X squared plus 3x. Now I have my space equals negative 2 and the same equal space. Now it's time to figure out what the right b is. So we take our positive 3, we divide it by 2, and that is just the same thing. So we do have to square it, and we get 9/4. This is the perfect number I want to add in. I know a fraction doesn't seem like it's perfect, but it is. It's perfect for the 3. Now it's time to rewrite. X plus what? Remember, you can look right over here at the thing that you squared. 3/2 squared equals, and now I have a little bit of side work to do in case you forgot. -2 plus 9/4, put it over 1, multiply the top and the bottom by 4, get -8/4 plus 9/4 equals 1/4. 1/4. Now it's time to square root both sides, and we get x plus 3/2 equals, the square root of 1 is 1, the square root of 4 is 2, don't forget to put your positive and your negative. Now it's time to subtract 3/2 to both sides, and I have two problems to do. The first problem is -3/2 plus 1/2, and the other problem is -3/2 minus 1/2. So I get -2/2, -1, and -4/2 is equal to -2. And those are your two answers. In this last example, I'm going to show you what you do with the number in front. The way to deal with the 3 in front of the x squared, since it wasn't there for the other problems, is to factor it out like a GCF. So first let's pull out the 3, x squared plus 2x plus 5 equals 0. And now that there's a 3 out in front being multiplied, the way you can get rid of it is divide it. And now I'm left with x squared plus 2x plus 5 equals 0 still. 0 divided by 3 is still 0. So now, at this point, I can start to make some space. -5 on both sides, and x squared plus 2x with my space equals -5 with an equal space. Let's analyze the b. The b is 2. So 2 divided by 2 is 1. Then we square the 1, and we still have 1. So our perfect number to add to both sides is +1 and +1. Factor out the left-hand side. X plus what? Well, remember, always look here at the thing that you squared. It's 1, and so that's square. Equals -5 plus 1 is -4. Now it's time to get rid of the exponent. Square root both sides, and I get x plus 1 equals, a -4. Both now you guys realize that that is an I, so that is I to I. -1 on both sides, and your x is going to be -1 plus or minus 2i. And there's your two answers. Remember, if you have any questions, leave a comment, email me, and I will see you in class.